Okay, okay, okay. All right, I'm going. Thank you. Hello, can you hear me? Hello, can you hear me?
Yes.
Yeah. So, I couldn't make it to the campus, so I decided to have this remotely. Okay, now we are now entering a new chapter, which I believe is chapter 6. So in any case, let me just take you to your class. But if I open this on this side, you can see my announcement for week 11. So we're in chapter 6, yes, I believe. So I have 3 assignments due this week. Still assignment 4, classwork 5, and homework 6. So by Thursday, I will have finished grading Excel assignment 1 and Excel assignment 2, and classwork 3. By Thursday, they'll be graded. Then, okay. Now, let's begin. The topic is probability distributions. So I will start by explaining the concept first. Before I do that,
Wait, I'm sorry, Dr. Ochi, I have a question.
yes, ma'am.
Were you saying that you're gonna put the Excel work out on Thursday?
Except I say Excel assignment 1 and Excel assignment 2. It's already
I know I was saying, you're gonna put the explanation out on Thursday, or are you gonna do it today?
I'm going to grade it. It's already
Oh,
it's an assignment that was submitted.
no, I'm talking about the new one though, because it's one due on the 14th. I mean,
Yeah,
no, stop. It's a new one due in I
yeah.
think in April. And I was saying, when are you gonna put that explanation out?
It's there already. The video, I put a video there for you to watch.
Oh, okay. Thank you.
Yeah. So once you log in, go to the site, you see the link to the video.
Okay.
All right. So now, of course, you can have access to all this on like scrolling down to the model 5. You can see them here, classwork 5. I'm gonna put this after the class is over today. Then Excel assignment 4. Actually, I want to put this on Thursday. Yeah, but I might put it today. Then Excel assignment 4. So, but based on your question, let me see. Yeah, I think you can see it. Based on your question, if you click on this, open, you can see the video right here. Watch the video before you now do it. Follow the same steps. Okay. Now, let's begin. Again, the topic is probability distribution, and I'll begin from the basics, which is random variable. Random variable is a variable whose values are determined by chance. Example, we have a die. If a dice is tossed, the outcome can be 1 showing up, 2 showing up, 3 showing up, to the last one. So number of siblings that a Morgan State university can have, we have no control over. Number of siblings your classmates have or has, you have no control over that. They can have any siblings that we don't control because we don't know them. I'll just meet them in the school, and on your own side, it's a random variable, you know. You don't know how many siblings whoever you meet will have. Yeah. Now, so on and so forth. Now, discrete random variables is the name we give to the finite and or infinite number of possible values that can be counted. They are discrete, which means that they can be counted. They are countable. Example, number of people who are jogging at Patterson Park. Okay? Number of people who are jogging at Patterson Park. You can count them. Okay? You can count them, and you cannot say you can say one person, only one person is jogging. You cannot say 1.5 people are jogging. You can't say that. Or that 2.5 people are jogging. I cannot say that either. Okay? How about this? You check number of eggs that a hen lays in 1 week. Okay? You can count them. You cannot say 1.5 eggs or 2.5 eggs, but you can say 1 egg, 2 eggs, 3 eggs, you know. Number of TV number of telephone calls received after a TV commercial is another example. So now, but continuous random variables are the one that we cannot count. Instead, we measure them. They are obtained from data that can be measured. Things like height, temperature, voltage. They are continuous random variables. Which bring us down to what we have today. But today, this week and next week, we'll be working on those, you know, continue on discrete probability distribution. A discrete probability distribution is the values a random variables can assume and their corresponding probabilities of those values, you know. So the values they can assume and their corresponding probabilities, call it discrete probability distribution. We have example like binomial distribution, Poisson distribution, and hypergeometric distribution. For continuous probability distribution, we have normal distribution, uniform distribution, and exponential distribution. Now, for this class, we will be focusing on binomial and normal distribution. So normal distribution will be, I will introduce it next week, Thursday probably. Let's start with the more explanation of the discrete probability distribution. Now, as I explained already, it is a probability distribution. It is so called because it consists of values that the variables, discrete variable can have, plus their corresponding probabilities. Okay? Now, let's look at, for example, look at this, it says here in this question. Construct a probability distribution for rolling a single dice. You can see the dice right here. I can see the sides, 3 showing up or 6 showing up in this case. Or it can be 5 showing up, or it can be 3 showing up, it can be 1. So I listed them here. 1 to 6. All the outcomes that we can observe by rolling the dice. And each of those, remember the question says, construct a probability distribution for rolling a single dice. So a probability distribution simply means the values that a random variable can have and their corresponding probabilities. So in this case, for the 1 to show up, the required probability is 1 out of 6 chances. For 2, same thing. For 3, it is the same thing. For 4, they all have the 1 out of 6 chances. 1 out of 6 chances. 1 out of 6 chances. Okay? 1 out of 6 chances is the required corresponding probabilities. Now, with this, you have answered the question. The outcomes and their corresponding probabilities. That's it. Any question on this? It's easy, I believe. So let's proceed to the next one. Now, look at this example here. It says, during the summer months, the BMZ Rental Incorporated, which is a rental agency, to keep track of the number of chainsaws it rents each day during a period of 90 days. Number of chainsaws rented per day is represented by the variable X. The result are shown here. Okay. 0 chainsaws on 45 days, 1 on 30 days, 3 on 15 days. Say compute PX for X. PX means the probability of X. Then it says construct a probability distribution and graph the data. Okay. Now, in this case, we have, it says, A part says compute PX for each X. So let us do A first. Okay, I'm going to copy this. And paste it here. I'm going to move this down so we can have enough room. So you can now construct, calculate, compute PS for each X. So I'm going to add a section here that it will be for PX. That means the probability. Okay. I'll draw it right here. Okay. Expand it. So this will be our PX. Okay. So I'm going to put it in. So I have the first one will be first thing to find the total before you can calculate PX. And we have that on number of days they rented no source, 45 days. So 45 plus 30 and 15. So I'm going to write this down so we can get it from the calculator. 45 plus 30 plus 15. Have 45 plus 30 plus 15. Give me 90. 90, okay? I'm going to go there and put 90. 90. See? Oh, sorry, mistake. Put 90 right here, total 90. Now, we cannot, with that, we cannot answer the question. The question says, compute PS for each X. So that means PX, remember we added it. Sum of PX is 90, so it's 90. I'm going to write 90 here because sum of PX 90. This means sum of PX is 90. So make it okay. Now with that we cannot calculate the PXs. Oh, I missed it. Sorry about that. Let's find the PX. We have for the 0, we have P0, that is the probability for 0. Maybe the probability for 0. That's what it means. That they didn't rent any chainsaw. On 45 days, they did not rent a chainsaw. So that means going to be 45 over 90. 45 divided by 90, can have it on the calculator. That 45 divided by 90 equals 0.5. That'll be right here. 0.5. So I'm going to put it right here, 0.5. Now let's find P for 1. The probability for 1 have, that is the probability that they rented only one chainsaws be 30 out of 90. 30, I should make it bigger. Make it 18. Have a 30 divided by 90. So we go to our calculator to find, change it to 30. 0.3333, that means 0.33. 2.33. 2.33. So I'm gonna put it right here. Then the probability for that they rented 2 chainsaws. P for 2. Excuse me. P for 2 chainsaws are rented equals, you can see right here, 15 out of 90. 15 out of 90. Okay. Piece number 90. We have 15 divided by 90. Change this to 15. 0.16666, that means 0.17. Okay. 0.17. 0.17. So we have it, because the question was compute px for each x. We have just done that. Then part B says construct a probability distribution and graph the data. Okay. So this is what we use, but I'm gonna make this is part A. Okay. Part B says the construct a probability distribution for this. So I'm gonna just paste this table right here. So then just remove this center. So you can see that we have the outcomes and their corresponding probabilities. That is the probability distribution. Now we have it right here. Now it says draw the graph. So let's draw the graph for this. So I'm going to do it in this form. Okay. 0.1, because it goes from 0.17 to 0.50. So I'm going to be 0.1, 0.2, 0.3, 0.4, 0.5. Then here you have, for us we have 0.12 for x. 0, 1, 2. Let me extend it a little bit more. Okay. Now we can now put our, oops. We can now put our diagram here. Okay. I'll insert it. Okay. Now put this line. Okay, that is the outcome x, which is the number of chainsaws, right? Yep. The number of the see the number of saws rented. Yeah. Okay. The number of saws rented, which is our x. And this one is the px, probability of x. The probability of x, px. Okay. I think I'm going to make some adjustments here. Makes my just minor adjustment, you know. Okay. Minor adjustment. Minor adjustments. I can just adjust this a little bit. Yeah, right here. Right here is good. And then move it a little bit further. Now I can now px. And put it next other line, which is goes from here. Okay. Now for 0, you have 0.5. 0.5. So 0.5, you got to draw it to 0.5 from 0 all the way to 0.5. Okay. Yes, for 0 is 0.5. And for 1 is 0.33. 1 is 0.3. So 0.33 should is 0.3. 0.33 should be around here. Okay. You know. Okay, now for 2. You're gonna be, maybe I should extend 1 a little bit. Oops, excuse me, sorry. For 2 is 0.17. So it's gonna be 0.17 or 0.1 is around here. 0.17 should be around this neighborhood. Okay. For 2. So that's the best we can get from that graph. Okay. So we have the graph. Now, see, you can see that trend is trending down. So we have calculated the required probabilities here. We have our probability distribution here, and we have the graph here. Any question on this? Any question?
No.
Okay, good, excellent. Now, at this point, we're going to review the 2 requirements for a probability distribution. The first requirement is that the sum of the probabilities of all the events in the sample space must equals 1. So that the sum of all the probabilities of all the events in a sample space must equal 1. Look at this first example we did. If you add all the probabilities we have, we're going to have 1/6. Okay? I'm going to make it like this. 1/6 for the first one. Add all this. Plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. Okay. 1/6. How many of them we have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That'll give us 6/6, which equals 1. So here is 1. Okay. And the same thing with this one. If you add all the required probability we have here, you can have that in computer again. Sum of x, I'm gonna have it this sum of x. This one here. I'll copy it here. So sum of px, I have it here. Actually, the 0.5 plus 0.33 plus 0.17. Now let me write this down and then we can add it. 0.50 plus 0.33 plus 0.17. Okay. Let's go add it. Calculator. Okay. 0.5 plus 0.33 plus 0.17. 1. So that's it satisfies the first. If it's less than 1, then it is not a probability distribution. So that's the first requirement. Second requirement is this. The probability of each event in a sample space must be between or equal to 0 and 1, which means that the probability cannot be a negative number, and it cannot be a number greater than 1. So that is what we use. Yeah, I mean how we figure out if a distribution is a probability distribution. Let's apply it here. See here, determine whether each distribution is a probability distribution. So to do that, we test whether it has satisfied the first requirement or the second requirement. Let's see. For this one, okay, let's see if it satisfies the first requirement. In that case, we have, I can see the X is right here. And I can see the PX. So add all the PX. 1/5 plus 1/5 dot 1/5 plus 1/5 plus 5. So how many of them? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that will give us 5/5, which is 1. So the answer is, okay, yes, because the sum of the probabilities. It says here, the sum of the probabilities of all the events, the sample space, okay, of all the events equals 1. Yeah. Any question on this one? Yeah. So there's no question, we can now go to the next one then.
No questions.
So this one says, is this a probability distribution? This one you don't even need to do any math because you can see right there. Remember the second requirement. Second requirement says the probability of each event in a sample space must be between or equal to 0 and 1, which means that they can never be negative and they can never be greater than 1. Okay, in this case, this one, the PS is negative 1.0. And this one is 1.5. So the first one is greater than 1, and the other one is less than 1. So less than 0. So that means the answer is no, because one of the probability, one of the PXs is 1, is negative, has a negative value. While the other one has value that is greater than 1. value that is greater than 1. Yeah, answer that. Answer the question. Next one is this. Let's see. We will know until we add all of these numbers. So small px equals small p equals 114 over 8 over 16 and over 6. So let me write this down so we can go and add it on the calculator. 1 over 4 plus 1 over 8 plus 16. Okay. Number 16, sorry, my mistake. So let's go and put it in the calculator. You have 1 over 4. One over 8. Over 16 plus 9 over 16. You can see that it's 1. Yeah. So that is 1. One. So the answer is yes, because some of the probabilities was 1. Okay. So you might try this one at home as a practice for you. I'll go to this kind of question. It says, yeah, determine determine the required or missing value of B to make the distribution a discrete probability distribution. Now you can see that B is missing. But you already know that the requirement is that first requirement is that some of the probabilities of all the events in the sample space must equal 1. So having that in your mind, you can solve this one. So that means everything here should add to 1. So to find B, all you have to do is to subtract everything from 1 to 1 minus 3.41, 3.02, 0.5. Yeah, please use your calculator. I'm write this down so you can go and do the calculator. Okay, plus yeah, I put it in equal. Put it in a calculator. Okay, 1 minus 3.02. Oh, excuse me, 0.141 plus 0.02 plus 2.33. 0.24 is the answer we got, 0.24. Oh, let's do the calculator. Oh, I wasn't showing the calculator. Okay, let me do the calculator right here. Clear it. 1 minus 0.41 plus 0.02 plus 0.33. Give 0.24. So let's go and put it right there. 0.24. Question on that? Any question? Yeah. It's no question. Yeah, good. Now, at this point, we're ready to review the mean, variance, and standard deviations of a probability distribution. The mean, variance, and standard deviation of a probability distribution. So the mean is given by this formula x times px. Remember, we have done the mean before, but we did it for a frequency distribution. This one is for a probability distribution. Variance is sum of s squared times px plus mean squared, and the standard deviation is simply the square root of variance. So let us try this. Says okay, we have says Davis Williams is the president of the Middle River Community Bank. Mr. Williams feel that each savings account customer has on average 3 credit cards. That was his claim. The following distribution represents the number of credit cards each people own, number of credit cards they own, and the required probability. So you have no credit card has 0.18, one credit card has 0.44, and so on and so forth. And it says here, find the mean, variance, and standard deviation. Then ask yourself, is Mr. Williams correct? To do that, we make a table in this form. This is one way of doing it. This is the shortcut method for doing this. So you form a table like this. Okay? Where you have x, px, x times px, s squared, s squared times px. So you get the answer for all this. From that, you can now calculate the mean, the variance, and the standard deviation. So let's get this part. Say x times ps, that means 0 times this. Each number here multiplied the number here. So 0 times 0.18 is 0.00. 1 times 0.44 is 0.44. 2 times 0.27. That one I can get from the calculator. Okay. 2 times 0.27. 0.54. Sorry, 0.54. Yeah, 0.54. Next would be 3 times 0.08. It's another target. Okay. I got 3 times 0.08. 3 times 0.08. Okay, 0.24. Okay. So I did that already. So I'm doing the second time. Sorry, my mistake. What I'm doing is there's this one. We're doing the other one. This is 0.24. I didn't write. That's why. And the last one is 4 times 0.03. Um, 4 times 0.03, 0.02, 0.08. So you got 4 times 0.02. Oh, 0.03. Okay. 4 times 0.03. 0.12. Okay. Now, we need to get all the answer for all this. Get x squared. S squared means square all these x's. 0 squared means 0 times 0, which gives us 0. 1 squared means 1 times 1, which is 1. 2 square means 2 times 2 is 4. 3 square means 3 times 3 is 9. Okay, 4 square means 4 times 4 is 16. Now, we need this part to be able to get this one. So we're going to do x squared times px. That means this one here times px. So I mean 0 times 18 is 0.00. 1 times 0.44 is 0.44. Then 4 times 0.27 here. 4 times 0.27. Okay. 4 times 0.27. Okay. 1.08. 1.08. 1.08. Okay. 1.08 for this one. And that's 9 times 0.08 here. Nine times 0.08. 0.72. 2.72. Last is the 16 times 0.03. 16 times 0.03. But 16 times 0.03. So is it gonna times okay 0.03, okay. 0.48, 0.48. 0.48 right there. 0.48. So now we add this part, then we can be able to answer the equations. So let's add this one, s times px. I'll write it down so you can go and add your calculator. 0.00, 0.44, 0.54, 0.24, 0.12. Now add it. Okay, let's see. Here we go. So I have it copied down. So let me go and just go and put it in a calculator. I got 0.00 plus 0.44 plus 0.54, 0.54, 54 plus 0. Plus 1, 2. 1.34. Yeah. 1.34. That's our mean right there, which is approximately 1. Okay. And the variance is in this form. Sum of s squared times px and as mean squared. So let's this is for 1.34 right here. Let's add this one. So I'm gonna put this calculator. Write it down. 0.0044, 1.08, 0.72, 0.48. Let's add it. Let's add them. 0.00 plus 0.44 plus 1.08 plus 0.22 0.48 48 2.72. I got 2.72. I did that. So I'm go over there and put it right there. 2.72. Right here. 2.72. So I'm gonna mean here, and the variance is square root of s squared times ps. Sorry, sum of s squared times ps minus mean square. That means this is s squared times ps. This is the sum right here. 2.72 minus mean, which is 1.34. Okay. 1.34 squared. So let me square it. See? And that will give us a variance. Write this down. 2.72 minus 1.34 squared. Go and put it on the calculator. Okay. 2.72 minus 1.34. Yeah. 0.994. That means 0.92. 2.92. 2.92. And the standard deviation will be the square root of that. Because the question says, okay, find the mean, variance, and the standard deviation. We got the mean and the variance. So when the standard deviation, it won't allow me to put the formula here. So I'm going to get it from the other workbook. Okay. This one. Okay. Let's see. So we have okay, standard deviation. Make it bigger. Will be, I'm gonna put this right here. Okay, we have square root of variance. Oh, put the wrong place. Square root of variance. The square root of variance. Okay. So the square root of the answer we got for variance. What do we got for variance? For variance, we got 0.92. That means square root of 0.92. Okay. 0.92 equal. So the square root of 0.92 is 0.96. Yeah, 2.96. I want to share this here. Okay, but let me share it again. I'm gonna share this one. Yeah, we've got 0.92 and 0.96. So I'm going to copy this and paste it in our main workbook, which is this one right here. So we are answer part A. Part A say calculate the mean, variance, and standard deviation. This is our mean right here, 1.34, which is approximately 1. This is the variance, and this is the standard deviation. Then part B says, is the Mr. William correct? Is he correct? Remember, his claim was that he was claiming that each credit savings account customer has on average 3 credit cards. That was his claim. But our average here, which is the mean, is 1.34. So his claim was not correct. His claim is not correct. Why? Because each of the savings account customers has only one has an average of 1 credit card. So no, because each of each savings account customers has an average 1 credit card. 1 credit card. Yeah. So any question on this? Any question on what we have covered today? Excellent. No question. Good. Excellent. So when we meet on Thursday, we'll continue from expectation or expected value on Thursday. Okay? Can you hear me, guys? Hello? All right. So I see you guys on Thursday then.
Have a good day.
You too.